Alright, so this is chemical equation sheet number 2. We're still practicing balancing chemical equations and identifying chemical equations. So if we look at number 1, first thing we need to do is identify the type of reaction we have. So look at your key at the top to help you with the definitions and just narrow it down. A synthesis reaction is two or more substances combined to form a single new substance. That is not the case in number 1 because we have two substances formed. So it's not a synthesis reaction. A decomposition reaction is when you start with one substance and it breaks down into two or more substances. We are not starting with just one substance, so it is not a decomposition reaction. Next definition, a single replacement reaction is when you have one element replacing another element in a compound. So what we're looking for is a compound and a single element by itself. And what's happening is this single element is going to replace one of the elements in the compound. And that's exactly what's happened here. Na has replaced one of the hydrogens in H2O, forming a new compound, NaOH and H2. So this is going to be a single replacement reaction. Now we're ready to balance. Now the equations on this paper are going to be a little bit harder than the ones that were on the sheet from yesterday, but you still follow the same steps to balance. So the first step is we're going to draw our line to separate our reactants and our products. The next step is to count out the atoms that are in each element. So Na, we have 1, H, we have 2, and O, we have 1. Looking at the product side, I like to keep them in the same order to make things a little bit easier to keep track of. So Na, we have 1. Hydrogen, be very careful. You have 1 hydrogen here and you have 2 hydrogens here. And this will give us a grand total of 3. But instead of writing it as 3, we want to write it the way we see it in the equation. So we're going to write a 1 and then a 3 separately to indicate that it's in 2 different compounds. And then for oxygen, we also have 1. Now, if we look at our two sides of our equation, now we see that sodiums we both have 1 of, and oxygens we both have 1 of. So the only compound, or the only element that's not balanced, is hydrogen. So the best way to do this, if you have an element that's in 2 different compounds, look for the one that has an odd number of elements. That should not say 3, that should say 2. Let me fix that. There we go. Okay, so we're going to start with the compound that has an odd number of hydrogens and try to make it even. So that would be this compound here, NaOH, and in order to make this 1 an even number, we simply put the coefficient 2 in front of the entire compound. Now when we do that, that changes our Na. We times everything by 2 that the 2 is in front of. So it changes our Na to 2, our oxygen to 2, and it changes this hydrogen to 2. And it's important to note that we still have 2 hydrogens over here. So our total number of hydrogens is now 4. So now if we go back and look at our reactant side, we have some fixing to do. The sodiums are no longer balanced. We have 2 on the product side and only 1 on the reactant side. So that's an easy fix. If we put a coefficient of 2 in front of the sodium, then that's going to balance our sodiums. Now looking at our hydrogens. We have 4 on the product side and only 2 on the reactant side. So if we put the coefficient of a 2 there, what's going to happen is everything behind the 2 gets multiplied. So this is going to change our H's to 4, which is good. that balances our H's, and our O's are going to also be multiplied by 2, which will give us a grand total of 2 oxygens, which is perfect. That's exactly what we need. And so now this problem is done. If it helps you, you can put a coefficient of 1 in front of the hydrogen over here, but you don't need to. If there's no coefficient, it's implied that it's a 1.